Today, we will be talking about technical session number 22, which is virtualization. And I am on the wrong slideshow. That's just fantastic. Many apologies. Let's update our links here. Promise I'm not trying to confuse anybody. So today we will be talking about client-side virtualization. Setting up virtual machines, different types of virtual machines we would have, what kind of requirements those may need, when would we want to do something like this, and so on and so on. Our objectives for this particular technical session are going to be able to define virtualization and describe its purpose. It has a couple. List the requirements needed to step up and use virtualization, or to set up and use virtualization. Describe how to use client-side virtualization and identify potential pitfalls to using client-side virtualization, including security concerns like VM escape. Real quick, based on what we've talked about before, and just basically what the word is, how would you explain virtualization to somebody who is not into computers or a client? Take a moment. Okay, so if you get a chance, I would recommend go ahead and taking a screenshot of this or snip this, just because it's a pretty good quick breakdown, as well as the next slide, which gives you a visual representation what a hypervisor itself looks like. So this is just some real brief, quick notes as to what they are, the differences between the two, and some examples that you may come across in your day-to-day activities. Give about 30 seconds here, give it a thumbs up and you got your screenshot and you're ready to go. Thank you. Thank you. Moving through. All right, good deal. Next, here is a good visual representation of what the type 1 versus type 2 look like. You have your hardware here on the type 1. There is no operating system layer in between like you do on the type 2. And then your guest operating systems or containers operate on top of that, and your applications will operate within those containers. Understood, Tajma. But you are back up and with us today. Right. Client-side virtualization requirements. Obviously, if we're going to try to run multiple operating systems on one physical workstation, it will require more resources than just running a single instance. Now, for performance reasons, if you are using a workstation, we're going to have you to create these instances, specifically if it is a type 2. These will divide the resources between the hosts and each virtual machine you are creating. So the primary resources we need to pay attention to are CPU, predominantly. How many cores do we have? And remember, if we have multi-threading, one core can act like two, right? So if we have a 4-core processor with multi-threading, that essentially gives us 8 cores to work from. Because each of the 4 act like 2, doubling the amount of cores we have. So CPU, RAM, and hard drive space, and then as well, network performance if these are going to be on the internet. If you're operating in a sandbox environment, you may not want them having any internet access. You may want them fully contained. So you can do it either way. Depends on the type of testing you're doing and what you're using the virtual machines for. All right. CPU, multi-core processors are recommended since the hypervisor can treat each core of a processor as a separate virtual processor. In some cases, it can create multiple virtual processors off of a single core, depending on the CPU you're utilizing. Now, some hypervisors require that your CPU be specifically designed to support virtualization, like Intel VT or AMD V. In most cases, it's not automatically enabled. You have to go into the UEFI or the BIOS and turn on virtualization from there. I know what you're asking. Is there somewhere we can practice doing these things? You're in luck. There is a test out lab. Sometimes we actually think ahead. All right. Next, memory. RAM is always a concern. And, typically, speaking, when somebody says, well, how much RAM do you need? As much as I can get. You want to have as much available as possible to allow for as many processes to run as you can efficiently. Now, the hypervisor itself will allocate the existing RAM between the host operating system and each virtual machine. However, you need to have at least the minimum required in order to run the virtual machine. And we know this based off of the minimum requirements for 64-bit and 32-bit operating systems, right? That's not going to change. We need to be able to allocate that RAM to run those VMs. So if a host operating system requires 4 gigs and then the guest operating system requires 2, then you would need a minimum of 6. So it gets added up together. And that's minimum, bare bones. Obviously, if you can get more than that, it allows for greater performance, but you need to have at least the minimum. Now, if you're installing a hypervisor that includes a full operating system on it, you need to have the free storage space to be able to allocate for it. So if we're installing a 64-bit version of Windows, how much hard drive space do we need? Silence. I'm gonna get a recording of crickets. Just play it.
Is it 4 to for the
You're thinking memory. I'm talking storage.
Is it 20 gigs?
20 gigs for a 64-bit. How much for a 32?
$16.
15. So we need to have the amount of hard drive space to allocate for it. It could be, we want to give it a little more than that because we're going to be able to run these instances, long term, and we want to be able to save stuff. like other applications we're adding to it, things like that. We need to have the space that we need for it allocated properly. All right. Now inside, what is this? What am I looking at here? Somebody tell me. I'm having an amnesia moment. What am I looking at?
In the book, it talks about that you can enable and disable virtualization mode on your computer. And over here in the BIOS, you can see that they're enabling CPU virtualization in the BIOS.
Very good. In the BIOS. That's very nice, but in more modern systems, what are we likely to run into?
UEFI.
UEFI. Very good. Very good. So in the BIOS, this is where we would go under advanced processor configuration to enable our virtualization technology. Don't worry. Practice is available.
Yeah,
Next.
we had a test out lab when we did that.
Amazing. So there is a test out lab for it. I'm so happy. It is a great tool. It is a great tool. All right. Now, if you're going to allow these to interact with the network, each virtual instance can have its own IP address on the local network, so it can communicate on the network. So the virtual machine itself will create a virtual NIC and manage the resources of that NIC appropriately. Obviously, you would be sharing a network connection between all of the virtual instances, but each of its own instances will have its own NIC to communicate. The virtual NIC does not necessarily have to be created to the physical NIC. It can be an entire virtual network within the same workstation, but not have access to the outside. So you can do that as well. Yes, Umberto. You muted yourself again.
Right.
No worries.
The IP addresses for the virtual machines are assigned by the same DHCP server that did with the real machines?
They can be, or you can statically assign them if you wish. So just like a regular NIC, you can assign them or they can be virtually assigned. Here's another fun point. You remember back when we were talking about wireless networks and one of the security methods that they have that with regards to CompTIA, it is a security method where we talked about MAC filtering. So each NIC has its own MAC address, right?
Mm-hmm.
So we can MAC filter basically stating, only these MAC addresses are allowed. Here's where you get around that. In setting up your virtual NIC, you can create a spoofed MAC address and put in whatever MAC address you want. Meaning if you can determine a computer that is on that system and know what its MAC address is, you could go ahead and put that in for your virtual NIC, and now you have bypassed that MAC address, that MAC filtering security. That is why we say, though they state it as a security measure, it really isn't, because it doesn't take a whole lot of knowledge to be able to create a virtual NIC and then implement your own MAC address to bypass that security. Because when you are creating that virtual NIC, it'll say, do you want us to generate a MAC address for you, or would you like to input one in yourself? Questions so far?
Can you repeat the last thing you said about generate or?
Yes, when you are creating the virtual NIC, because when you're creating a virtual instance of a computer, you can set it up with whatever hardware you wish. You can create virtual switches, virtual routers, virtual NICs. So when you're creating this virtual NIC, when you're installing it, it'll give you the option of saying, hey, do you want us to generate a MAC address for this NIC, or would you like to input a MAC address for this NIC? And that is where, when you input that address, that allows you to spoof you're able to spoof a MAC address of another system if you so choose, and bypass MAC filtering. Any other questions? All right. Now, every hypervisor that you install has its own way to set up virtual switches to create virtual networks within your own system. So you can have 10 virtual instances running on your physical server, and then a virtual switch between them controlling that communication. And each instance would have its own virtual NIC. So every host operating system you've created now has its own virtual NIC. You have a virtual switch that they can all communicate with, and then go out through the physical NIC. But obviously, when they go out through the physical NIC, they are sharing that communication, that bandwidth. Now you can configure it to where they can only communicate with each other internally and not go outside, or you can allow it to go outside, in which case your physical NIC operates as a bridge to get to the network resources outside, and they would have just as much access as the main system that it is running on. Questions so far?
In this instance, what is the bridge networking? Is it that virtual switch?
Well, if I'm allowing these exterior communication, my physical NIC is operating as a bridge for them to get to the outside. So, does that answer the question?
Yes.
All right, Mark. Video.
With the virtual networks, if we go to ipconfig, well, the command line, can you ping those locations, or how does that really work in the virtual environment?
Okay, so if you're operating on the same server and you're trying to, if you have these all networked together, then yes, virtual machine 1 can ping virtual machine 3 if they are allowed only to interact locally, like on the physical server. So internal virtual network. So yes, you can ping each other. They can interact with each other just as they would out in the real world. Now, if I allow them internet access and they're using the physical NIC as a bridge, then yes, I can ping other systems outside, and other systems outside can ping these systems, because then they're operating almost as if they are physical units. Yes, Humberto.
Oh, yes. Even working with the bridge networking, I still have the possibility to assign to the virtual machine the fake MAC address, or
Yes.
or not anymore?
No, yes, you do. See, the fake MAC address comes when you're installing that NIC, that virtual NIC, because you can go down and customize it and say, you know, here's my MAC address, here's my IP address. Now, if you're going to allow it to go out into the physical network, if it is not, the IP is not within a range that's allowed on that network, that would prevent it from being able to talk. So it would still need to adhere to the rules of the network it is on with regards to IP addresses. Questions so far? All right. Security requirements for virtual machines. Now, basically anything that would have, the concerns you would have for individual computers will hold true for virtual machines. So you would need to have malware protection and stuff like that on there if you are running these for a longer period of time. They are vulnerable to hackers, just like regular machines. There are cases when you would intentionally infect these to see how the viruses operate. If the VM itself has access to the internet, it must be protected and isolated from the host and have permission secured for files in the VM holds. Now, you must ensure your guest operating systems have antivirus programs, and those programs are kept up to date. If the person making the attack understands that what it's attacking is a virtual machine, they may be able to perform what's called a VM escape, where they can get outside of the virtual machine into the main host and infect everything. So there is that danger when you're running that. Yes, Humberto.
So the virtual machines will belong to the same domain as the physical machines and will obey the Active Directory.
Yes, if there's an Active Directory set up, yes. If you're working out of your home network, it won't be the same. You would need to basically adhere to the same rules that you would for your own internal network, is what it comes down to. So if you're in an enterprise environment and that's running off of the domain, yes, if they are going to be operating outside of the server itself, they're not just running an internal network. If it's just internal inside the one system, you can do whatever you want with it. The moment you step outside, you have to adhere to the rules of the outside. All right. What's the difference between a hypervisor and an emulator? The emulator differs in the fact that only the emulator can be running at any given time. It runs one type of program on a platform that is different. For example, emulators can be used if you want to run like Android-based games on a Windows PC, or old Nintendo games or old Sega Genesis games. There's a lot of fun emulators out there where you can actually download a lot of these games for free and play them on your computer. It tends to be very slow and bog down resources pretty quickly. So it actually is more resource efficient to run a virtual machine with the specified operating system that it's required, and it works a little bit better. And although colloquially people will use emulator and hypervisor interchangeably, they are different things. So a hypervisor can run multiple operating systems, and emulator runs one type of program. It has a very specific purpose. All right. Now, the only requirement for an emulator versus a hypervisor is that it is compatible with the host operating system. That's it.
Rita?
All right. Any questions so far? VDI, or virtual desktop infrastructure. This is essentially the process of running a virtual desktop inside a VM that lives on a server, usually in a data center somewhere. Has anybody ever operated off of virtual desktops? I am fairly certain Marisha has, because that is a big thing in schools. Anybody else? knowingly operate off of a virtual desktop? No? Okay.
What would be the benefit of having that in a academic setting?
It's cheaper to have a whole bunch of thin clients than have a whole bunch of full-blown PCs with full operating systems running on them. So you have a singular place where everything logs into, and then you run the operating system from there. Also, here's the nice thing. If I save things to my desktop in a virtual machine or on a virtual hypervisor, the beautiful thing is if I go back and say I log in at Marvin's desk, all my save stuff is still there. It's like I'm sitting at my own desk. It doesn't matter where I log in on the domain, so long as I'm logging into that virtual machine, I have all my files. So it allows you to be significantly more mobile. Like if I traveled from here to Spartanburg and I log in on my, to my sign in and password or whatever for their system, I still have everything as if I'm sitting here at my desk, rather than me having to carry either a laptop with me, email files ahead, carry, jump drives, all that kind of fun stuff. It's all already there saved. And then hardware wise, you're saving money with regards to, multiple thin clients versus multiple thick clients.
Is that something that they use in hospitals too?
Yes. Hospitals. Marvin would better be able to speak to that than I would. But yeah, hospitals, real big in retail and stuff like that. Most cash registers are just thin client computers. They have a monitor, a keyboard, a full keyboard. If you notice, they have a mouse, they have the barcode reader. And then underneath, they actually have thin clients that are just connecting to the host server in the store itself. And then those will upload to the main server at the end of the night. So real big in point of sale, POS. You hear that term a lot. And yeah, office work is pretty common, stuff like that, just because if you're operating your own private servers and stuff like that at your office, it is significantly cheaper just running off thin clients. So, all right. Now, other thing is it is a pretty powerful form of desktop virtualization. And like I was saying, where you could save your files, you could fully customize and personalize your own desktop, and then it will save that for you. So I can have my own backgrounds, anything I want to do to it, I can personalize it myself. And then when I log in, it gives me everything that I have. Grants the much greater freedom and mobility. I don't necessarily have to be at my own location. I can go anywhere else, and as long as I can log into the server, I have access. So that would be virtual desktop infrastructure. All right. Next, we're going to go through the steps, general steps, to follow when using client-side virtualization. So first, we'll determine whether or not the client actually needs to utilize virtualization. Evaluate the computer that you're going to be putting this on to ensure that it can support the VM, based off of CPU, RAM, hard drive space, network capabilities, what have you. Which hypervisor are we going to use? Currently, the most popular one is Oracle's VM. Was it VM box? VirtualBox? There you go. Oracle's VirtualBox tends to be the most common one, and it's free. So please feel free, go out, download it, give it a shot, practice. Security requirements. As we talked about, you got to treat each virtual instance, if it's going to have access to the network, as if it is an actual computer. And then install the hypervisor and guest operating system. All right, first step, installing the hypervisor and running it. VM or VirtualBox. So go out, Google VirtualBox, go directly to their website, download the one that's compatible for your machine, be it for Windows, Linux, or Mac. Always try to get the most up-to-date version, so go ahead and install it. Next, you'll open up that application, and then you create a new instance. It's pretty straightforward. Click on Machines, click New, and you can start creating a new instance of a virtual machine. Three, what are you going to name it? So I recommend giving you a name that identifies exactly what the machine is. Like you could call it like Windows 7 Service Pack 3, you know, and maybe give it a little bit extra if you're doing specific things to it or you're testing specific things. Make sure the name will tell you what it is, not just VM1. Because if you have 20 or 30 VMs running, you may forget which one is the one you need to look at. After that, you need to tell it what type of VM you're going to be running, what operating system are you going to be installing it on there, so that it knows what you're going to be looking for. And then, you know, so you have Microsoft Windows for the type, and then below you have your versions. You know, we're doing Windows 7 Service Pack 2. Are we doing Windows 8? Just so we can realize how bad that operating system actually was. So you would make this determination here. Go ahead and click next to move through it. And we just talked about that. You select the guest operating system, which you're going to be using. And then after that, you're going to allocate resources to the virtual machine. RAM, hard drive, CPU cores, Ethernet, optical drives. What resources are you going to allow it access to? So in this function, we would be determining that. It'll tell you how much RAM you have, and you can, you know, run the slider right here. Oop, back up, run the slider here, back and forth to tell it, because like the red would be what is required for your host operating system, green would be your availability, and you just run the slider across to determine how much RAM you want to allocate to the system, which will be eaten up the moment you turn the system on. Core allocation and storage. Am I going to give this thing just 25 gigabytes, you know, just to have a little bit extra for some applications? Or am I going to give it like a full 100 gigabytes? It's going to be an ongoing virtual machine that I have running. And I'm going to be testing it long-term for applications and stuff like that. All right. You can add extra resources that it has availability to, like we were talking about, optical drives. Does it have access to your USB ports on your system? Storage capabilities, like if you have RAID arrays, do you want it to have access to that? Audio, is it going to have access to your speakers or microphones? Network, you know, are you going to put the virtual NICs in there? This is where you put in the virtual NICs, assign them IPs and MAC addresses. Do you need virtual switches to communicate between the virtual machines on your individual system? Shared folders. Is it going to have access to some of the folders on your system or no? Is it going to be completely isolated? This is where you would allocate any extra resources you want to have the virtual machine to be capable of. Questions so far? All right. Next, you should be all set to go. Click your start button. Let it power up. It should open up in the window just like it is a brand new desktop. First time you start up, you have to install the operating system just like any other machine. So you can have these files already saved on your main machine where you would save them. go ahead and install them. If you're going to do it off of a thumb drive or an optical drive, you can go ahead and do that as well. But once you get everything installed, you should be able to run it as you see fit. All right. Questions so far? Here's a big one. Not necessarily for the test, but just for general life. One of the things people who are new to virtual machines forget to do is power down the virtual machine. Because you think you can just X out, you're good to go, fine, walk away. No, you actually have to power it down. Otherwise, it's going to continue to utilize the resources you have allocated. The storage will remain allocated, but your RAM will get freed up once you have turned the machine off. So if you have 30 different virtual machines on there, you may not have enough RAM to run 30 at the same time, but you can run 3 at the same time. But you just got to remember to take the time to power down each time when you're done with your instance so that you can free up those resources. Any other questions? I promise we'll put this up in Slack so that you can go through it, just so you have the steps readily available. If you want to go ahead and create a virtual machine on your computer, I highly recommend you give it a shot. They do have Test Out Lab creating a virtual machine, which is also good. There's also the sandbox at the end of Test Out, which allows you to play around with a lot of this stuff as well.
Is that something you can do even though you don't have like extra RAM and stuff like that on your personal computer?
Well, I mean, in your personal computer, you may have enough RAM to run 2 instances. Like I'm sure, you know, it's likely you have more than 4 gigs of RAM in that computer.
Okay.
So if you have 6 gigs of RAM, you could run your main operating system, which is likely Windows 10, and then you could run a 32-bit instance of Windows 7, because that would only require 2.
Pardon. Go ahead. Sir.
So yeah, you likely could. I mean, you just need to look at your system requirements, see what you have available for your system, and you can play around with it.
Is that a good idea to, is it a good idea to use a virtual machine as a way to, let's say if I want to let someone else use my machine, instead of them using my regular login or just like a guest login, is a virtual machine a good way?
Well, the problem is if they're logging into a virtual machine on your system, like if it's a guest at your house, they still have access to the main operating system because all they have to do is power it down and they're now in your main system. Now, if it was somebody remoting in, that would be different because then they would only have access into where you allow them in, which would be like the virtual machine or something like that. But if it's somebody physically there, they already have access to your system. If they physically have access like this. So my recommendation would be to create a secondary user on your computer. So you would have yours, which have all your files on it. You have your administrator, which is your main one. And then you create your normal user, which is the one you use day to day. Create a third one. Don't use a guest account, but create a third family account or something like that. And then just name it, you know, Renzi's guest. And then you don't allow them access to any of your internal files. So they would only have their own. So if somebody comes in, you log into Renzi's guest, you allow them to have access to that. They can't see any of your other files, photos, videos, none of that, because you would mark that as private. And then they would just have like a basic desktop to be able to go to the internet and check their email or what have you. So that would be the better way to handle that situation.
So that's more secure for me also.
Yes, rather than creating a virtual machine.
Okay, perfect.
Because if they physically have access to the computer, they're already in. If you're using a virtual machine, because all they got to do is shut down the VM and then they're in it as if they were you. So create a second user on your computer and that will help. Any other questions? All right, so just a reminder here, power off your virtual machine when you are done. Free up those resources for other things. Pitfalls of virtualization. Now, when you set up the environment, it's really no different than doing a clean install of Windows. You can have a variety of installation issues, just like you would on a regular host. Basic solution, follow the steps for installing and reinstalling when needed will resolve most installation issues. The best part about a virtual machine is literally you can just delete it and start up a new one. If you create a really good one that you like all the settings that you have preset, you can create an image of that. So when you build a new virtual machine, you just build it from that image and you don't have to redo all those settings again. You can just duplicate from that good image you've created of the virtual instance. All right. Now, big issue that we've talked about multiple times throughout this technical session is virtual machines use resources as the host. So use the same ones. So the basic solution to this is before you start running them, ensure you have enough RAM, CPU power, storage to be able to handle the VMs before you start running them or installing them. Security concerns, you still have the same ones you do with a normal computer. You have your secure permissions, your firewalls, malware, secure locations, all that fun stuff. Main solution that they offer up is make sure to keep all your anti-malware systems up to date. And remember, if you have it on your main system, it does not mean you have it on your virtual. So you would have to install it on the virtual as well. Questions? All right. We'll bypass this one for now because we want to go right to the quiz. Well, with that, we should now be able to define virtualization and describe its purpose. List the requirements needed to set up and use virtualization. Describe how to use client-side virtualization and when to use it. And identify potential pitfalls using client-side virtualization. Hint, a lot of times it's just like when you're dealing with a regular computer. Same fixes typically apply. And if things get particularly out of whack, you can always delete and recreate the instance.